Hello everyone, this is my chemistry project. I'm Gomana Asfour and this is my chemistry project on the red cabbage experiment. So first of all, water. Is water neutral as we think? Water can act as both an acid and a base. And it's relying on the strength of the acid and the base the reaction is occurring with. For instance, if the substance is a stronger acid, the substance will act as a base. Water is special because it can self-ionize. So water undergoes self-ionization when two water molecules they form a hydronium ion and a hydroxide ion, like the one shown in the picture. And this happens by the transfer of a proton. So what happens is that random changes in the electric fields surrounding the atoms in the H2O molecules make the molecule break apart. And then a proton, or we can also say a hydrogen atom, will break off the H2O molecule, and it will go to another. And it will form a hydronium ion and a hydroxide ion. And this explains why water can act as both a base and an acid. So this implies that water can react with itself. Then here we have the Kw constant. So in chemistry, there's a standard notation showing the concentration of these moles, the hydronium and the hydroxide moles per liter. So first of all, we have the hydronium, and it is the molar ion concentration is equal to 1 × 10 to the power of -7 m at 25 degrees Celsius. And then hydroxide is also equal to 1 × 10 to the power of -7 m at 25 degrees Celsius. These values, no matter what happens, they always stay constant in water at a constant temperature. The equilibrium constant, Kw, is called the dissociation constant or ionization constant of water. And what happens is that you multiply hydronium and hydroxide, so 10 to the power of -7 and 10 to the power of -7, and you will get 10 to the power of -14 at 25 degrees Celsius. And the thing is, the Kw constant is directly proportional to temperature. So as it increases as temperature increases, because ionization of water increases as the temperature increases. So although the concentration of hydrogen and hydroxide are only equal in pure water, perfectly neutral solutions, the products of the two concentrations will always remain 1 to the power of 10 to the -14. What is pH? pH indicates the power or concentration of hydronium in a solution. Mathematically, we define pH as the negative. There's two meanings. So in chemistry, we can say it indicates the power or / concentration of hydronium in a solution. But then in math, we define it as the negative log, the negative log of the concentration of hydronium ions in a solution. And here's the formula, as you can see. pH has a Dutch phrase, and this phrase, as you can see here, it translates to the hydronium power. That's why certain scholars will put pH as a measure of the concentration of hydrogen and not hydronium, and the negative, and they would also define it as the negative of the base 10 log of the concentration of hydrogen ions in a solution. So instead of using the old formula and the old meaning, they would use hydrogen instead of hydronium. For example, if we have a solution at 25 degrees Celsius and its concentration of hydronium is 1 × 10 to the power of -5, then the pH is the log of it. So what will happen is that we'll get 5 in the end. Then why do we have pH written like that? We have P, which is lowercase, and then H, which is capitalized. Why is it written like that? So basically, so there's a lot of beliefs about this because it's not confirmed, but so it is believed that P isn't capitalized but H is, because H is an element. Because as I've said previously, some people believe that H refers to hydrogen. So they believe that H is capitalized, so it's going to represent like an element, while we don't capitalize P, so it doesn't represent an element like phosphorus, for example. Therefore, capitalizing P would lead to confusion. Hydrogen is represented by the letter H in the pH. However, there is another debate about like P. It stands for like the power or like strength of hydrogen. And according to the Carlsberg lab, which was the lab that had like the pH discovered in it, that's what it stands for, like the strength of hydrogen. However, other German chemists, they believe that the claim, they believe that it stands for the word potens, which means power. So they believe it comes from them. While French people are trying to claim it and say that it is from their word for power. So each country, like there's until now like 4. One that's talking about the elements, and one that's from the lab itself, which just says it's like the power or like the strength of hydrogen. And then the Germans, which are trying to say it came from their word, and then the French, which are also trying to say like that came from like their word for like power. So they both believe it means power. However, like as I've said, they argue about where it came from. On the other hand, it is believed that it is derived from the common habits of chemists of differentiating a test solution. So they just believe it's random. Like while like the discovery of it, like they were just trying to differentiate between the test solutions, so that's why it was named pH, like as a usual chemist habit. Who discovered pH? So who is Soren Sorensen? He's a Danish chemist who was born in 1868. He studied at the university. Even though he was like the son of a farmer, he was going to pursue a career in medicine, but then he consulted a chemist called S.M. Georgeson, and he chose the career to pursue in chemistry after speaking to him. He's well known for his discovery of pH, which is what we're speaking about, and he has other works as well, such as development of formal titration of amino acids named after him. He participated in a geological survey of Denmark, and he served as a researcher for the Royal Naval Dockyard before working as a chemist. His wife, Margrethe Heirup Sorensen, she helped him with his research as well and then he died on like the 12th of February in 1939. That was his death day, and he was about 71 years old during that time. Soren Sorensen was director of the Carlsberg Laboratory Department, which was funded by the Carlsberg beer company, brewing one of the longest chemical industries. Biochemistry was the objective of like the laboratory, or the lab, which was established by the same named brewery. He wasn't directly trying to discover the pH scale. He was trying to work on like the role of iron concentration in protein research at the time, while conducting experiments with beer at the world-renowned Carlsberg Research Lab. He discovered pH. With the support of his wife, Sorensen proceeded on like becoming an expert in the application of the effects of iron concentration on protein. Professor William Jensen was trying to figure out how would the experiment of Soren Sorensen look like, since we don't have any visuals, and this is what he visualized. This is not exactly the picture that came from Soren Sorensen himself, but it was what he visualized according to old writings. So this is number 1 and this is number 2. The pH scale. The pH scale, it measures how acidic or basic a solution is. And then we have the transition interval, which is the range in which an indicator changes color. POH. It is defined as the negative log of the hydroxide ion concentration, and this is the formula for it. And the sum of the pH and the POH is always 14. In any case, both of them, when they're added together, is going to be 14. Acidic. Acidic is a solution in which the H3O concentration is bigger than the OH concentration. As acids, they have a pH from 0 to 7, and 7, which is gonna be a neutral substance. A lower pH value indicates a stronger acid. Strong acids. Strong acids are substances that ionize completely and conduct electricity well. So nitric acid, sulfuric acid, perchloric acid, and hydrochloric acid. Weak acids. They do not completely ionize. And we have citric acid and acetic acid, which is basically vinegar. Acids can be characterized by a lot of characteristics, like a sour taste, turns blue, indicator, red, and it tastes sour. And for example, we have lemon. Lemon fits all of these characteristics. It will turn the indicator red, it has a sour taste, and it's a citric acid. A basic solution, the OH concentration is greater than the H3O concentration, and bases they have a pH level from 7 to 14. A higher pH level indicates a strong base, and acid is a proton donor, while a base is a proton acceptor. And it turns an indicator into blue. It has a bitter taste and soapy to touch. Strong versus weak bases. A strong base in a solution is one that is fully ionized, like sodium hydroxide. A weak base if it is less than 100% ionized in a solution, like ammonia. A neutral solution. So neutral is when the hydronium ions and the hydroxide concentration, they are both equal. One is not greater and one is not less than the other. And it is 7, the pH of it is 7. And negative pH values can happen, and values that are above 14, they can also happen, but they're very rare and very dangerous. But we also have here an example. So if we have the pH of 12M, hydrochloric acid is calculated to be the negative log of 12, which is going to be negative 1.08. So this is a situation where negative pH values can happen, but at the same time it is very rare for it to happen. An indicator. A pH indicator is a chemical that turns different colors at different pH levels, and they change colors because they are either a weak acid or base. This is some extra knowledge. So the pH of a swimming pool must be checked regularly, and that is because maintaining the right chemical balance in our pool water helps us keep us healthy. So it keeps the water clean, so it protects any of any harm to us, and it not only to the human body but also to the boiler, the pump, and other metallic machine components from injury. And it will keep the pool look more fresh than usual. And the acidity of pool water is measured by its pH level. The pH in your blood, it is also known as the acid-base balance. It is the ratio of acids and bases at which the body performs best. The human body is designed to naturally preserve a stable acid-base balance. This is where the lungs and the kidney come into action to help maintain this type of balance. So now we're on the experiment. The experiment is called the red cabbage experiment. The question is, what will happen when you pour like a soapy liquid, a soap mixture, or like baking soda and lemon juice and red cabbage juice. So what I think will happen is that the juice will change color according to the pH of the substance that is poured on it, like poured in with the juice. Okay, so this is my experiment. Basically, I turned red cabbage into juice, and now I'm gonna pour different liquids, like different solutions, to try to see what color would the cabbage juice change into. So this is lemon juice. This is baking soda from this mixed with bottled water, and this is soap mixed with tap water. So now we're going to pour the baking soda with the first cup. As we can see, the baking soda turned the solution blue. Now we're going to take the soapy water and put it in the second cup. And here the soap water turned it purple, a lighter purple. And then now we're going to try the last cup with lemon juice. So this is our lemon juice. Ideally, lemon would turn it either red or like an orange. As we can see here, it's a bright red color for the lemon, and here it is for the baking soda blue. Here it's a bright purple, and here it's a bright red. Okay, so for the soap, I'm going to try to have a second attempt to turn it purple. So this time, instead of using hand soap and tap water, I'm going to use tap water and dish soap. We're going to try to see if it's going to turn pink or not. So now I tried mixing it with the spoon, the dish soap and water solution with the cabbage, and when I mixed it with a spoon, it came a pink solution, and it was comparing to the last one, which gave us a bright purple and didn't really do much of a change, but this one gave us a pink solution. So to end this, the baking soda gave us a blue color, the hand soap with water gave us a bright purple, and the lemon gave us a red, and the dish soap and tap water solution with the cabbage juice gave us a bright pink. My observation for the baking soda, that it turned the juice blue, meaning it is around like a pH of like 7 to 8, and it is probably a weak base leaning on the neutral side. And then for the lemon juice, it turned the juice red, indicating that it's very acidic. And soapy water, it turned the juice pink, indicating that it is a strong base. Explanation and conclusion. So my explanation is that when red cabbage juice, which is an indicator, is combined with an acid or a base, it produces like a water-soluble pigment that changes the color in an acidic environment with a pH of less than 7. The juice will turn red, like the lemon juice, for example, when we put it with the cabbage juice. And in a basic solution, or like basic situations, with a pH greater than 7, the juice turns bluish green, and like for the first time when we tried like with the soapy water. And then for the conclusion, the red cabbage juice is a pH indicator, a chemical that turns different colors at different pH levels.